I would like to take about 20 to 25 minutes and talk about the nature of pornography addiction, what it is. It's hard to fight an enemy if we really don't understand what we're dealing with. And so tonight, let's spend a few moments and talk about the science. I may skip some of these slides because I would like to spend at least half of the time talking about healing and about hope and recovery. But I think it's important for us to spend a few moments and talk about what we're dealing with. And so you might wonder why we have a waterfall on the screen. Well, let me tell you a story, and some of you may have heard this. If you've read the book, you've read the story, but I'd like you to hear it from me. We were in Africa a few years ago. I had served a mission there and had marvelous experience of visiting some we had taught when I was a missionary, and just had some beautiful experiences with them. But while there, we also took opportunity to visit Victoria Falls and to participate in a safari, and it was wonderful. The Victoria Falls is, some say, the largest waterfall in the world in terms of volume, in terms of the amount of water going over the falls. And we flew to a safari camp in these little bush planes, landed in the middle of nowhere on these little dirt strips. They had to circle them once to make sure the elephants weren't on the strip. And then we land, and these Land Rovers pick us up and drive us to the safari camp in the middle of nowhere, right on the Zambezi-Zimbabwean border on the Zambezi River, the Zimbabwe-Zambian border on the Zambezi River. A lot of Z's. And so we're there in this camp, and we're right on the water. And we took these pictures. I took the falls from the plane. I took this from our camp there, and this hippo it was right out in the water, and there were a crocodile about every 30 yards. And so the ranger said, "Be very careful. I know it's pretty. I know you're excited to be here, but there's dangers. You have to be careful, particularly around the water." So we were careful and cautious about getting around the water. And then he pointed to this grass that you see over here, and he called this adrenaline grass. And so I'm asking him, well, why do you call it adrenaline grass? Okay, what's that about? So this grass over on the side, this grew on both banks, so this adrenaline grass is on our side as well. So we're in open-air Land Rovers with no doors and no windows, and he starts driving through the grass, and here we go, and we're looking for game, of course, and he says, "Whoa, do you see it?" And we said, "See what?" And he's driving closer and closer and slow, and so look right at that dark area. Suddenly, there it was. It was hiding right and going back. There it is. It's hiding. In fact, his paw is sitting about there. His face is right there. His other paws are there. So now he's sitting there by the river watching the water. And believe me, he is watching that water. You can tell. Of course, he was kind of watching me taking the picture right then. And so as my heart began to thump through my chest, I looked at the ranger and said, "Okay, I get it. Adrenaline grass. Right." So that's why we call it that. And so several object lessons there. One, yes, it's a brain drug in the sense that adrenaline was produced by my brain. So there are brain drugs. My brain is a really efficient chemical factory. It made adrenaline right on the spot, produced it, put it into my bloodstream, systemic effect, my heart's pounding in my chest, and I'm ready to run. Wouldn't do much good, of course, if I did. In fact, the lion would like that. Cat and mouse, it would make it a little more interesting probably. But, so what's this adrenaline? I thought it was a drug. I thought to find adrenaline, we have to go to a hospital crash cart as a physician. But we can make it in the brain. So which one, is it a drug if we buy it at the drugstore, if the pharmacy gives it to us, if we take it off the crash cart at the hospital, or is it a drug if our brain makes it? Of course, both. It's the same thing. It's the same chemical. It's a drug either way. Also, just to interject Peter's statement here, to extend the metaphor, 1 Peter, be sober, he said, be vigilant. Great words for recovery. For your adversary, the devil, as a roaring lion, walketh about seeking whom he may devour. That's what pornography does. It strangles. Lions kill by strangling. And that's how pornography kills. It, as President Hinckley said in his talk on pornography, it strangles the life out of relationships. So what about brain drugs? This is adrenaline, and this is dopamine. So they look very similar, but you'll notice there's that methyl group for you chemists out there, and so the methyl group is the only difference. They're both catecholamines. They're close cousins. They're both go drugs in the brain. They say go. Let's move, let's run, let's act. And dopamine is actually very important in movement. In fact, when dopamine is depleted in the brain, then Parkinson's disease results. And you probably know someone, some of you may struggle with this disease, but basically when we don't have enough dopamine in the motor systems of our brain, we can't move well. And the person with Parkinson's will move very slowly. So what do? You'll know if you know someone that has Parkinson's disease, that we give them dopamine. We give them drugs that cause the dopamine to be elevated in the brain, and they can actually move while they're taking the dopamine. They can move again and actually function. Well, dopamine, and so they're both brain drugs. If we buy the dopamine and go to the pharmacy, it's a drug. If our brain makes the dopamine, it's still a drug. Our brain just made it. It's a very good, efficient pharmaceutical laboratory. Well, dopamine has a second purpose. It's also very important in pleasure. So, dual purpose. Just take this as a take-home message. Dopamine, very important in movement, but also very important in pleasure. And what it does is dopamine is produced right here in this area, in the midbrain, in the VTA, and in the substantia nigra. Both of these areas are dopamine-producing areas. And it sends wires, both of these areas send wires to the motor areas from the substantia nigra. This is the Parkinson problem for that. And this little pathway from the VTA to this nucleus accumbens. That's another word you may want to remember. You'll hear that in the popular press. That's a key pleasure center in the brain. It's a little almond-sized area. And that nucleus accumbens is very, very important in pleasure. And when dopamine stimulates the nucleus accumbens, the person wants pleasure. Dopamine is probably very important in valuing and liking pleasure. Now, the nucleus accumbens has other chemicals that also stimulate it. The opioids are probably more important in satiating pleasure, in enjoying the pleasure, but the dopamine says you want that pleasure, go get it. And so when it spikes, anytime a pleasurable activity is experienced. I have other slides I won't show tonight that shows in animal models spikes of dopamine. Food spikes dopamine. Sexuality really spikes dopamine. So does cocaine. So does heroin. They all spike the dopamine in the brain. Chocolate spikes it pretty well. I'm sure Godiva Dark would really spike my dopamine in my brain because I love it. So what about this? This is the frontal cortex. Now, the frontal cortex is right up here behind my forehead. It's the brake of the brain. It says, whoa, horsey, stop, think about it, don't do it. If you do, you're going to be sorry. And so these areas have an interplay. Now, Dr. Eric Nestler wrote a paper in 2005 called Is There a Common Pathway for Addiction? Dr. Nestler is one of the most respected addiction scientists on the planet. And you can say that anywhere, and everyone will say yes. Anyone that knows anything about addiction will say yes. Dr. Nestler is very credible in this field. He was chairman of psychiatry and neuroscience research at Southwestern in Dallas for years. I understand he's at Mount Cedars-Sinai in New York now. He wrote this paper in 2005 called Is There a Common Pathway for Addiction? And in this paper he said, you know, for years we've looked at cocaine, methamphetamine, and we found that, yeah, they're real addictions. They spike the dopamine pathways. But now it appears that natural rewards, in other words, natural consumption of rewards that we experience to help us survive, like food and sexuality, can also be hijacked in the same way that drugs hijack the pleasure center. So is there a common pathway? Do all roads lead to the mesolimbic dopaminergic systems? He wrote in his paper, published in Nature Neuroscience. And so this diagram is from that paper. So what's interesting about it, This is a dopamine cell, normal on the top. Look on the bottom, it's shrunken. And lo and behold, he said, we know that with drugs, what happens is because of a downgrading, the cells actually shrink. They get smaller. What happens is the brain, in acting out an addiction, let's say we experience a pleasure and we get a dopamine spike. The brain says, thank you, that's a good pleasure, I want that. But when the person starts to become fixated in addiction, and it's not a garnish to life anymore, dopamine reward becomes the main event, the main course, then things start to change in the brain. And what happens, those cells actually shrink. They get smaller, and they produce less dopamine because the brain says, you know what, the dopamine and the pleasure are great, but you're killing me. It's too much. I have other things I need to do. So almost as a defense mechanism of sorts, it downgrades and shrinks that dopamine cell. It gets smaller. So now, look what you can see what happens now. Does the person have the same amount of dopamine in their new resting state? No. So what do they feel like now normally, just walking around? Not as good. Does a normal meal do it anymore? Or whatever it is they've conditioned themselves to, does normal sexuality within marriage, does that suffice anymore? No. What happens now is to gain that same spike, because of shrinking circuits, so to speak, the person must boost the dopamine. And to just feel pleasurable or normal, because they have fewer receptors as well on the dopamine receiving cells in the nucleus accumbens, they must boost the dopamine, the amount of the dopamine, the bigger hit. They must hit the brain harder with a stimulus to produce the same effect. So, for pornography addiction, it's softcore to hardcore to child pornography. And it basically causes, to just feel pleasant, the person must act out and increase that signal magnitude of dopamine. It resets the pleasure thermostat, the hedonistic thermostat of the brain. And another thing happens. Then that frontal area, that control area, that break of the brain up here behind the forehead that says, think about it, shrinks as well. It gets smaller. So not only physically, but functionally. So in a normal person, it's don't do it. Yeah, you really want this. No, you don't. Yes, you do. No, you don't. Don't do it. It's a no-go. And of course, in addiction, it's you really want this. Remember how good the last time was? You really want it. You don't want it? Yes, you do. No, you don't. It's a good this. In neurosurgery, we treat patients with brain injuries. And in other words, when this car crashes, you can imagine that person's forehead hitting the airbag or whatever and stopping rapidly. Well, the brain keeps traveling forward inside the skull, hits the back of the forehead, and frontal lobe bruises can result like this. This is blood. It's a frontal lobe damage. And in neurosurgery, many times, like this patient, I would likely take this patient to surgery, open the cranium, and remove that part of some of the frontal lobe and some of the blood so that the pressure would not kill the patient before they have time to heal. Now, what might this person be like after the surgery? They would likely exhibit what we call frontal lobe syndrome, or hypo means less, hypofrontality, less frontal control. Very common. So, what happens with this? What do we see with hypofrontality? 4 things. Impulsivity. I want to do this. No, never mind. I want to do that. Constantly switching, but impulsively. Compulsivity. I want that. Do you want this one? Nope, I don't want that one. I want that. Compulsive. Emotional ability. Fly off the handle. Blaming, critical, angry, tired, easily, emotionally labile, and impaired judgment. Not weighing it out, not seeing it beforehand. Well, okay, so we know that happens then in our neurosurgery patients, but what about an addiction? Okay, 4 studies, and I want you to follow this. Don't worry about getting the science on the slides. But I just put them up there so you'll know these are scientific studies that have been done that show this. This area is, that little colored area is the frontal area, and it measures what's called hypofrontality. Not in car wreck patients who've had their frontal lobe damaged, but these are frontal lobes that are smaller in patients with cocaine addiction. And this was published in Biological Psychiatry, peer-reviewed journal, back in 2002, I believe this one was. And then another one looking at the same thing, frontal lobe damage and shrinkage in methamphetamine addiction, published in 2004. Again, peer-reviewed journal. Well, I know everyone's thinking, well, yeah, but I mean, cocaine and methamphetamine. We all remember the commercials, don't we? The guy on the thing with the frying pan, he goes, see this? And he holds the egg up and he goes, this is your brain. Remember that? And he goes, and he drops it in the pan. And he goes, this is your brain on drugs. You remember that commercial? Made quite an impact. I still remember it. And I was like, ugh. So we don't have a problem believing that cocaine and methamphetamine are going to shrink the brain. But you might be surprised to know that in 2006, a study was done looking at obesity, morbid obesity. And lo and behold, frontal lobe shrinkage, it looked almost identical to the cocaine and the methamphetamine studies. A natural addiction, just as Nestler's saying, and pertinent to our discussion, a study looking specifically at pedophilia, but a severe sexual addiction, published in 2007 in the Journal of Psychiatric Research. Brain shrinkage as well. Frontal lobe shrinkage in sexual addiction looks almost identical to the cocaine, the methamphetamine, obesity studies. That's a wow. Okay, that's a wow. Because what we have are, think about this, we have 4 studies, 2 drug addiction studies and 2 natural addiction studies, okay, done by different research teams in different academic institutions over a 5-year period. No relation to each other, different addictions, published in different peer-reviewed journals, all showing the same thing. So we can shrink the brain, the control areas, with a car wreck or with... So, yes, it is. Addiction is a soul wound. And so healing must address not only the spiritual aspects, but it must also address physical recovery. And that's where recovery comes in. We'll talk about that in a moment. Are we lost? Is there no hope? Once we have shrunken brains, are we done for? No. Wonderful 2 studies, 1 methamphetamine, 1 obesity study, showing return to more normal volumes with recovery. There's another one I'm not showing a slide for that Dr. Volkow's group published in 2001. Again, showing looking at methamphetamine with dopamine receptor and showing return to more dopamine receptor function within about a year, year and a half of recovery. So it takes time, but with abstinence and sobriety, the brain can heal. So as published in the journal Science, as far as the brain's concerned, a reward's a reward, regardless of whether it comes from a chemical or an experience. And as Dr. Nestler said, natural addictions, he used this word, natural addictions, not compulsions, not bad habits, not weak moral fiber, but addiction, brain addiction, such as pathological overeating, pathological gambling, and sexual addictions. This is Eric Nestler, Journal of Neuroscience, or Nature of Neuroscience, 2005. So, and a word from Nora Volkow. Nora Volkow is the head of the National Institute of Drug Addiction and one of the most respected neuroscientists in the world. I dare say that if you mention the word addiction to anyone that knows anything about addiction research, they will know who Dr. Nestler is and Dr. Volkow. They will know those 2 names because these 2 are 2 of the most published scientists in the world. Now, whereas Dr. Nestler looks at mechanistic effects of brain cells with addiction, Dr. Volkow looks at brain scans. She looks at all those scans I showed you. She looks at things like that, looking at brain scans in human beings showing addiction. And she is probably the world expert in that. And she was quoted just a couple of years ago in the journal Science NIDA Director Noel Volkow also felt her institute's name should encompass addictions such as pornography, gambling, and food. And she recommended changing the name of the NIDA to the National Institute, I'm going to get this right perfectly, but she said the National Institute for Addiction Research. Get rid of the word drug, because she said it's not just drugs, that natural addictions affect the brain the same way drugs do. So we need to look more at addiction as a disease. So just carry this away tonight. This is true science. And not all therapists are on board yet. Many are learning. But this is what the addiction brain people are now saying. Okay. And just briefly, the oldest scientific journal in the world, this was started in the 1660s, the Royal Society of England. And last year, they published this report of a meeting on addiction, where they invited the top addiction scientists in the world to present 17 papers, which they then published in their journal. This is the journal, The Neurobiology of Addiction, New Vistas. And yes, 3 of the papers were about natural addictions, not drug addictions. And guess what? Eric Nestler was there talking about it, as was Nora Volkow, another paper on pathological gambling, on brain changes with these things. Dr. Nestler talked about something really interesting. I'll spend just a couple of minutes on this. He said that delta phos-B is a protein, and he's studied this extensively, which we see exclusively in the brain cells of addicted animals when he studies them. In other words, if animals eat normally or have normal exercise called wheel running or sucrose drinking, you see other phos chemicals in those brain cells, but you don't see this one. You only see this one in animals that have become addicted to their behavior. It's an addiction marker and probably an addiction workhorse. We think it probably actually functions as well. It's not just lazy. It probably helps the brain cell function negatively in addiction. Okay, what's interesting then is he started looking at natural addictions. You can see where I'm going with this. He looked at wheel running, not just the cocaine and the meth rats, which show delta phos-B. He looked at excessive wheel running rats, hyper sucrose drinking rats, and recently, just last year, hypersexual rats, and found that, yes, there's delta phos-B in those cells as well. I think, to me, this is the holy grail. This is absolute. Okay, the jury's in, verdict's over. Not only do you have the scanning images we just saw, but now you have the brain cell basic science model with the world-famous Dr. Nestler, incredible Dr. Nestler, saying there's delta phos-B in those brain cells. That's pretty much it. And as he said, this powerful statement just published in 2008, in addition to drugs of abuse, natural rewards induce delta phos-B. Now, get the significance of this. When he says induce delta phos-B, he means addiction. Not compulsion, bad habit, weak moral fiber. He means addiction, true addiction. Levels in the NAC, which is the nucleus accumbens. Remember that almond-sized area we talked about? That's NAC. Our results raise the possibility that delta phos-B induction in the nucleus accumbens may mediate not only key aspects of drug addiction, but also aspects of so-called natural addictions involving compulsive consumption of natural rewards. Dr. Cower and Malinka at Stanford, in their landmark paper on the actual cellular mechanisms of addiction that occur, addiction represents a pathological yet powerful form of learning and memory, which then can chain the individual to the behavior. A monkey, Dr. Rizzolatti, scientist that studies mirror neurons, studied individual nerve cells in monkeys, and he noticed that these monkeys, when they picked up a peanut, the cells would fire, the peanut picking up cell, okay? And so then he noticed that the monkey, when it saw another monkey pick up the peanut, the same cell fired. And then people would pick up the peanut, the same cell fired. Other behaviors, cell didn't fire. So they became known as mirror neurons. And mirror systems in humans have been studied. And it's hard to put electrodes in human brains just to study them. Any volunteers we can... But with monkeys, it's easier to do that. But with humans, it's difficult. But mirror systems are widely agreed to exist in humans. Most scientists studying them believe that they do exist. They network. They're neural networking cells. Seeing is doing. Seeing is believing. And so a study recently published in 2008 out of France looked at individuals viewing pornography and found the mirror areas that are associated with mirror systems in the human brain where we see it and we're there, so to speak. They said, we suggest that the mirror neuron system prompts the observers to, and this is powerful imagery, resonate with the motivational state of other individuals appearing in visual depictions of sexual interactions. Wow. So seeing is being there, basically, with the brain. And this is Ike, before on the top and after on the bottom. Now, on the top one, you'll recognize that there's a beach there on the top, and there's not a beach on the bottom, where the waves have destroyed it. My family rented a cabin our beach house right about here when I was a senior in high school, and it's gone now. In fact, anyone that stayed in Crystal Beach, Gilchrist, and the Bolivar Peninsula when Ike hit died. Every one of them. They all died. No one got out. No one survived. 100 years ago when the Galveston storm hit, people died then, but they didn't know. Now, this didn't need to happen. Of course, the hurricane was going to hit, but people didn't need to stay and take this because we have advantages today which they didn't have 100 years ago with Galveston. There's the eye. This is Ike from a weather satellite, showing it barreling towards the Texas coast. So no guesswork was needed. Now, President Monson, just within the last couple of conferences, you'll remember his last remarks when he said to cease now if you have this problem. But he didn't just say to stop. I love what he said. He said, seek the help you need. He said, take the steps necessary. I was at a recovery meeting. We were invited, Jan and I, as missionaries, to attend a recovery meeting with Elder Madsen of the 70, who at the time was serving as the general authority over addressing the pornography problem. And he had been invited to this meeting as well. And at that meeting, I shared just some thoughts when talking about when President Monson said, take the steps. I said, we could even interject 12. Now, he's the prophet, but we could say, take the 12 steps necessary. Well, I was later asked to speak at a church satellite broadcast for an addiction recovery program, and Elder Madsen spoke on the same program. I was mortified when on the broadcast he mentioned what I had said, and I said, please, President Monson, don't be offended. And he said, no. He said, I don't think he would be offended. I'm going to use that. He said, I think he would be okay with it. Take the 12 steps necessary. And he used the word in that broadcast. And I thought about that. I thought about those 12 steps. And how we don't have to, we have a weather satellite. We have an eye in the heavens, so to speak. We have these inspired leaders to tell us. So what about recovery? Victor Klein, vast experience as a therapist. 4 things most predict success. Whatever it takes. Number 1, whatever it takes. Okay, that's it. I'm ready. Whatever it takes. Second, safe environment. Third, 12-step support group. Fourth, counselor therapist with success in treating